Kelsey pushes a box with a mass of 35 kilograms along the floor. She exerts a force of 213 newtons to the right, and it accelerates at 2.4 meters per second squared to the right. Okay, so this is another one where we're trying to find the coefficient of friction. Okay, so I think what we got to do is draw a little picture here. We got the box. All right, we got Kelsey. Oops. Pushing on there. We got to give her like ponytails or something like that. And she's pushing on the box, and it is 35 kilograms. And let's see. She's exerting a force of 213 newtons. I'm guessing that there probably is another force acting this way, right? So we'll call that, right, the force of friction. And I think what we're going to do is set up F equals ma, solve for what the force of friction is, and then over here, the other half of the problem will be we'll use the friction formula to figure out the coefficient. Okay, so the forces are 213 plus F. Now I know the F is going to end up being negative, but I always pretend that it's not negative. I always give it a chance first. Okay, and it's accelerating to the right, so it's 2.4. Okay, so now let's solve for F here. It's going to be 35 times 2.4 minus 213. That's negative 129. Okay, so we knew that the force would be to the left, and there it is. It's negative, right? Okay, so that's part of it. And then now let's figure out the force of friction. The formula is mu times the normal force. Okay, and so the normal force in this case is mg, right? So the force of friction ends up being mu times m times g, right? So 129. And this formula is just for positive numbers, so that's where the minus sign went. I'm just getting rid of the minus sign. I don't want to end up with a negative coefficient of friction. So mu times 35 times 9.81. All right, let's divide, baby. Divided by 35, divided by 9.81. 0.37, wow, that's 0.3757. Is my mu, so I guess with two sig figs I'd have to say 0.38. There aren't any units for that. Yay! This is actually a tiger that I'm drawing. All right.